On Tuesday, February 23rd, we have another live virtual show, this time to beautiful Torbay by the sea in southwest England. This part of Europe has a strong heritage in photonics packaging. In recent years, it has seen one of the biggest booms in merging semicon and photonics worlds. Which explains why Dutch telecom chipmaker Effect Photonics based its production facilities under an impressive rock by the seaside. And packaging specialists Bay Photonics were next door. But not for long. Everyone's moving in a few kilometers away to join other companies at the brand new Torbay high-tech cluster. So new that Google Maps still thinks it's a construction site. So why did it make perfect sense to bring all these companies together in one location? And why is there a giant Epic sign on both sides of the building? So join me on February 23rd at 4 p.m. CET, 3 p.m. in the UK, when we explore behind the scenes of the new Epic Center. We'll visit not one, but 4 photonic companies. Bay Photonics, or Epic Photonics prototyping gurus. For many years, they have been instrumental in the PIC revolution by providing a PIC package prototype designed for manufacturing. I really want to see inside their Epic prototyping room. I can't wait. Effect Photonics, one of the renowned success stories in the industrialization of indium phosphide photonic integrated circuits, enabling the next generation of DWDM transceivers. And we will witness firsthand how the die assembly and automated wire bonding machines of Palomar Technologies fulfill the dreams of any company that needs their integrated photonics packaged in volume. And if we can see the machines in action, that's going to be awesome. We are also going to see the automation microscopy solutions of Prior Scientific, bringing automated inspection tools with nano precision. Nobody will be surprised when I ask them the epic question. It's all about starting epic collaborations. Things can really happen when epic meets epic. A blanket covered brisket makes mama go ballistic. Ladies and gentlemen, welcome to the most tongue-twisting event in the history of Epic, where Epic meets Epic member Epic at an Epic meeting, which is going to be epic. The European Photonic Industry Consortium, EPIC, goes to visit the Electronic and Photonic Innovation Center, EPIC, all the way to Torbay, in one of the most beautiful areas of this beautiful continent named Europe, one of the most beautiful areas of the UK. We go to Torbay and we're going to visit 4 fantastic companies: Bay Photonics, Palomar Technologies, Effect Photonics, and Queensgate. But before we get started, let's go first live to talk to the person who made all this happen. Let's go to talk to Wayne Losky from Epic. Wayne, thank you very much for this amazing opportunity.
Fantastic. Thank you, Jose, for that introduction. A very warm welcome to Epic. For those that don't know, this Epic stands for the Electronics and Photonics Innovation Center. As you said, it's located in one of the most beautiful regions of Europe, I think, on the southwest coast in the UK. But in particular, it has one of the areas the area has one of the most densely populated photonics and microelectronics clusters in the whole of Europe. So we have businesses such as Lumentum, 26 Lasers, Gooch & Housego, Bay Photonics, Effect Photonics, Palomar, Prior Scientific, Spirant, and also new businesses that are within our centre, like CAS Antennas, who are working on ESA projects. We've recently taken on a Spanish MEMS company called NanoSense, who are very, very interesting. And also we're talking to a North American smart LED company. So that is either within Epic or within 3 kilometers. So just slightly further afield, we have companies such as Plessey and Artemis Optical as well, who are less than 20 kilometers away. So I think it's fair to say that the area is rich in innovation, skills, and photonics expertise. So it's fantastic to have you here today. Epic was opened just 18 months ago. We already have over 50% occupancy in the centre. We've only got 4 labs left to occupy, so I'm hoping to fill those soon, and we have a few offices left. So as I mentioned to you, the supply chain locally is very, very impressive, and there's a rich supply chain. So today you're going to meet some of the key members of that supply chain. So Palomar Technologies, Bay Photonics, Photonics, and Prior Scientific. So I'd like to hand you over now to Martin Davis, who's waiting.
No, wait, no, not yet. Not yet. I'm not gonna let you go that easy. So you say that you still have offices empty, and I really want to fill them. One thing that I was quite amazed with the work that you have done is that it is not just about bringing companies together, it's about making them cooperate. And like that, I could see that there is really a suitable supply chain. I could say Bay Photonics helping Effect Photonics, using the Palomar for the packaging, and using Queensgate as well as the solution for the automation manufacturing. What kind of, if you could ask the Santa Claus Christmas list, what kind of companies, what kind of profile of companies would you like to have to fill those few empty spaces?
Yeah, we're looking for businesses that want to complement the business we've got in here already. Businesses that potentially could work together with some of our existing tenants. Businesses that could maybe have joint funding bids. Businesses that maybe an early stage that will benefit from the £2 million worth of prototype and equipment that you'll see very soon. So a business can come into Epic, and overnight they can increase their technical capability and collaborate with some of the region's most specialist photonics companies. So it's a great opportunity.
This area with the cluster, it is really a great place also for incubate and raise startups. Is there any room for helping young businesses who need to benefit from the amazing supply chain that you're building?
Yeah, absolutely. So we certainly help the new businesses with maybe rent-free periods. We help them by making introduction to the local universities and colleges, and help them get the right people they need to really start their business.
Wayne, I really want to come to visit you as soon as possible. Today we have something amazing prepared, lots of surprises coming. Let's see what is next in your fantastic agenda.
Fantastic. So as I was saying, thank you for the questions, but next up is Martin Davis, who is waiting very patiently in our prototyping room, and he'll introduce Palomar Technologies and also some of the other technical capabilities that we have to offer current and future Epic tenants. Thanks,
I know Martin very well. He is a very patient man. Martin, how are you? It's great to see you live today.
Hi, Jose. And
oh my God, where are we? Where are we? Tell me where we are, because you're wearing clean room suit. Are we inside a clean room?
We're in the clean room in the prototyping suite here at Epic Painting.
I can tell you this is the first time ever in the history of Epic, 16 years, that we do a live show from inside a clean room. What class are we having here?
This prototype suite is just class 10,000, but we have a class 1,000 clean room on the 3rd floor at Epic for high rel and high performance assembly.
And you're surrounded by lots of fantastic equipment. Tell us what's around you.
Yeah, so my name's Martin Davis from Palomar Technologies in the UK. I've worked with Palomar equipment for 23 years. And just to give you a background on the Palomar brand itself, we started life in 1975 as part of Hughes Aircraft Division in California. And then 20 years later, in 1995, we became Palomar Technologies. And we're headquartered in Carlsbad in California, which is the golfing capital of the world. Stunning place with amazing surf, so you've got to get yourselves out there if you can. We've got an Asian headquarters in Singapore, and our European headquarters is in Erlangen in Germany, and another beautiful spot in Bavaria. And at each of these sites, we now have innovation centers. So these innovation centers can help startups, SMEs, get their products to market very quickly by having access to fully automated die bonding, wire bonding, and vacuum reflow solutions. So we can do DFMA, design for manufacturing assembly, rapid prototyping, all the way to volume production. Yeah, let me tell you a bit more about this prototyping suite here at Epic Painting. So we've got ESD flooring and benches so that we can handle microelectronic and photonic packages and components safely. We've got nitrogen storage cabinets so we can keep the materials and sub-assemblies in a controlled temperature and a controlled humidity. We've got plasma cleaning for preparation for wire bonding. So we've got argon plasma cleaning from Henneke. We've got epoxy curing ovens for epoxy, silver sinter, and we've got two so that we can keep them separate. We can keep the silicone material separate for contamination reasons. We've got chemical storage cabinet and chemical cleaning areas so that we can clean down the wet parts of the epoxy valves and epoxy daubing stations. And we've got a full metrology suite here, which is really impressive. I'm going to show you a bit of that a little bit later on. But we've got microscopes from Nikon. We've got a SEM from Joel, which is part of Nikon, so that we can really zoom in and look at facets and waveguides and look for defects or contamination. We've got a VMM from Mitutoyo so that we can perform incoming material inspections. We can check components are correct to drawing before we even start programming the machines and building valuable customer prototypes. So if I get onto the Palomar, this is our 3880 die bonder. I'll just start it going for you.
We're going to see the machine working live. And as every time a live demo goes live, we expect the best.
Yeah, so this is our Palomar 3880 die bonder. It's a beautiful balance of high throughput, high accuracy, placement accuracy, and repeatability across a huge work envelope. Starting with the top of the bonder, there's an 8-position bidirectional tool turret, and this tool turret indexes the tools on the fly as the machine's traversing in X and Y at 250 milliseconds. So you don't lose any throughput time changing tools. There's a dual LED lighting for programmable lighting that works with the Vision Pilot vision software.
Mm-hmm.
There's an in-process camera, so you can watch the tools in action, actually bonding within the eutectic nest, or epoxy bonding, or UV bonding, flip chip bonding. You can see everything live on the screen as you're bonding. So this is a really nice feature. So in a facility like EPIC, you need total flexibility, kind of like a contract manufacturing environment where you don't really know what the customer application is going to be. So this large work envelope allows us to present hardware and software options on the machine to cater for all applications. So we've got a eutectic nest here with vacuum and mechanical clamping. It's got a gas cover, so we can pump in nitrogen, hydrogen forming gas to act as a catalyst and get rid of the oxygen and help with wetting of the gold tin, or we can run indium tin, bismuth tin, SAC, gold tin, gold germanium, gold silicon, all the way up to 500 degrees C. We've got a scrub option so that we can scrub out any voids in that interface. This is the largest hotbar that we do on a eutectic nest. It's 58 millimeters by 50 millimeters. So your aluminium nitride substrates or your gold boxes will fit in there, no problem. In terms of epoxy bonding, we've got 2 types of valve. We've got a Musashi Jetta, which is strategically placed on the bonder for pressureless silver sinter applications. When you use this together with a bond line thickness control software, it gives a really accurate, repeatable bond. We've also got a Tecon volumetric dispenser. This is really useful for really viscous, really thick materials you can dispense with a really great degree of accuracy. And then for the really tiny components, we've got an epoxy daubing pot where we can daub down to sizes of about 100 microns daub diameter for picoliter volumes and really miniature components like 01005 surface mount components.
Martin, I'm quite amazed for the machines of Palomar. We're living really a revolution on the automation for manufacturing of integrated photonics. Companies like FineTech in the room, like IXMTech in the room, like of course Palomar today you're showing us. They are doing automation and machines that are serving a large variety of different products, because at the end of the day, this machine that we are seeing is packaging devices for many different companies serving many different application fields.
That's
How do
right.
you do the reconfigurability of the machine after using it for a transceiver and then you have to use it for a biosensor?
Yeah, exactly. So that's one of the main advantages of the 3880 die bonder, because it's got such a large work area. It's 908 millimeters by 514 millimeters of optical bench work area, where you can simply remove a hardware item, put a new hardware item in, calibrate it up, and include it in your programs. So it's super flexible. And in years gone by, we've had customers that configure them for NPI, but they design the work envelope so that they can add further levels of automation at a later date, so that once the product's gone from R&D through NPI into volume production, they can use the same machine through each part of the product life cycle. So typically, customers, when they buy these machines, it's a large investment, but the return on investment, you have customers that run these machines for over 25 years.
Martin, this is an epic meeting. Don't be surprised at what's coming. And what's coming is the epic question. What can you do for the other 690 members of EPIC, and what can they do for you?
Well, what we can do is we can offer design for manufacturing assembly, prototyping, we can do process development, and we can do volume assembly. And together with the collaboration that's going on in here with our friends at Bay Photonics, Effect Photonics, Prior, NanoSense, Blue Marble, together we're stronger as a cluster, and we can provide a lot of experience. We've got a lot of pedigree. We're all ex-Nortel, and this is the legacy of Nortel pretty much.
One thing that I'm seeing, especially in the automation for manufacturing, is that companies need to set up a process from the very beginning. When they are actually designing the first chip, they got to set up a process that also includes the equipment, and eventually many of them, and we have, for example, Iponics in the room, they want to do the whole production. How does it work? So they come to package the chips first with you, and then you can actually help them, assist them to set up a production line at their location.
That's right. So yeah, we'd engage in some initial discussions. We'd need an RFQ pack, a request for quote pack, which shows drawings of the components, any delicate keep-off zones for the key chips, how the materials are going to be presented to the machine, on wafer, on blue tape, on gel, on waffle pack, in tape and reel feeders. We need that kind of information, and then we need to know the project timelines, and we can provide a quote for any of those services, for rapid prototyping, for a route to volume. So, Palomar, we can put all our machines into one fully automated high volume assembly line. So really it's from that design concept, DFMA, prototype, NPI, all the way to volume production. So we cover die bonding, wire bonding, and vacuum reflow systems, so we can really get all those marginal gains out of your product, so it performs and has its best possible chance of success.
I'm a huge fan of the die bonding solutions that you have, but I want to actually talk about something that is, when I bring the different companies that we have in the room, of course, the floor is open for questions, so you have a question, please ask. I always wonder about the key question when it comes to automation, which is active versus passive alignment. It is clear that we are aiming for the integrated photonics and also, of course, semiconductor lasers, packaging, and assembly. Is there a room for cooperation with companies aiming more for the passive alignment? How do you stand on that? Or do you think that it should be done actively? What is the position of yourself or Palomar?
Sure. Well, we've sold these machines into photonics companies for decades now. And, even now, I would say 90% of a transceiver is built passively. And then it's just the final lenses and fiber or receptacle that has to be actively aligned. So, I think passive alignment, when for transceivers, I think to get the most out of the laser and the receiver, the alignment accuracy is probably 0.1 microns. So you're never going to get that with a passive bonder. It has to be actively aligned. It needs to be powered up. So I think you need a nice balance of passive capability to do your tech, your chip on carriers, your gold box assembly, and then you need your active partners then to do the lens and the fiber alignment.
All right, let's do partnerships then. I think
Let's do it
I have
together.
Rolf Sackler from FinTech all the way from Berlin in the room. Ralph, thank you very much for joining today. Do you agree with the statement that we had from Martin from Palomar that there is a room for both, and actually the final touches with the fiber, the final lens should be done actively, but the passively is for all the steps before that? Or is there further cooperation?
No, to be honest, I fully agree with him. It's like this, that we are going to push the border, the limit further and further towards the 0.1 micrometer that he mentioned. So we can reach 0.3 at the moment. It needs quite some preparation and so on, but it's possible. And we push the border even further. So I think that this 90% of the transceiver is still going to be made passively, even if the accuracy demands get higher.
I'm pretty well. I don't know, Martin, you want to comment on this?
Yeah, I agree. I think for most transceiver applications, I'd say that's true. There are other applications, some VCSEL ball lens kind of applications where if you're down at those 0.3 kind of placement accuracies, then it can be 100% passive. But the biggest challenge, I think, is the shrinkage of the UV epoxy when you cure the lens or.
And also you have to recognize something. So if you have a lens that is somewhere. And you don't have sharp edges or so, then this submicron alignment is, of course, more than a challenge.
Yeah, for years, I think we've been at the mercy of the mechanical tolerances of the incoming piece parts. The axes of the machines are down towards those kind of accuracy levels, but we can only build with the materials we're given, and it's up to the die bonder and wire bonder suppliers to really squeeze the best out of their hardware and software tools. To get a nice balance of throughput, first pass yield. And flexibility, particularly in somewhere like Epic, where we're collaborating with many different customers and companies with many different applications. So we need that versatility.
Martin, I never travel alone. I don't like traveling alone. I get bored in the plane. So I came with a lot of friends. You already met Ralph. You're also going to meet Dirk de Man from Topic Embedded Electronics. Dirk, what's on your mind?
Well, I heard an interesting statement that there are some wishes for software and hardware development and how you can make things better. If you would have a magic wand and you could solve all the problems, what would you desire to see?
Well, from my point of view, an improvement on incoming materials would really help us. But in terms of software and hardware, I don't know. When you're trying to passively align the edge emitting lasers with a facet that's been cleaved, it hasn't been diced, there's skirt on the facet. There's always a tolerance with the scribe process. So, as we move to PICs and PLCs and other smart integrated devices, being able to use some clever software to really find where that facet edge is, to align to the lens or to the fiber, without at the moment we have to just default to some fiducials on the chip, and there's always going to be that scribe and cleave tolerance of the facet. So if there were any clever ways of illuminating the side of the chip and using like strong Cognex or PatMax kind of vision software to actually find the facet, this would help us, I think, in the transceiver world. And hardware, we're always looking at low cost. People are moving away from hermetically sealed packages. So we're dealing more and more with epoxies and understanding those fluid dynamics and how they cure and how things shift during cure, CTE mismatches. If there was any software that could help us understand these epoxy materials in greater depth, that would certainly be music to our ears.
Well, I'm gonna play that music to your ears because, of course, I'm gonna make an introduction here. That was fantastic, and I want to reiterate this: if you want to use world-class machines for your prototyping and pilot production, this is the place to do it, and it's a unique opportunity to get them working for your first ever iterative photonics devices using Palomar technology machine. Thank you so much for this, and I can't wait for the next one. I'm a huge fan of these people. These are guru packaging people. Whenever you need your technology to be in a manufacture, in a design for manufacturing package, you need to talk to Bay Photonics. And today I had the pleasure to talk to two of my great friends, Glenn George and Andrew Robertson from Bay Photonics. Hello and good afternoon, all the way from the Netherlands, talking to Torbay.
Hello there.
How are you doing, Andrew? It's great to see you.
Doing very well. I'm doing very well. Thank you, Jose.
So we got out of the clean room now. We are now in the stairs. What are you going to show us?
Well, the stairs are very nice here in Epic, and what we'd like to do is try and give you a fly through of Epic, so that the building here, Epic, and we're going to talk to a few of the people because they know what they're doing. You know, I'm just a research guy. I don't really know. So there'll be other people talking. I'll try and give you a flavor of what we're doing. And this is a first, so bear with me.
We are going now to walk through the different. Oh, my friend Glenn is there. Glenn George, a fantastic logo on the wall. I really have to travel and see you and have a beer with you, Glenn.
Yes, we look forward to that, Jose. It'll be great. Yes.
I never seen what you're gonna show us live. You're gonna walk us a little bit through the prototyping lab. I'm so curious, so excited. What's it in your mind?
Glenn's going to give us a quick intro, and then we'll do that.
So I just wanted to say a few words about the background of Bay Photonics, who we are, why we're here, and then Andrew's going to take the camera along through the rest of our facility, which we occupy most of the second floor of this wonderful building. So yeah, I'm the managing director of Bay Photonics. It was established in 2007. Initially, our remit really was to continue to provide access to the vast experience that we'd gathered while working in the photonic packaging industry, which has a very rich heritage in this particular region with the likes of Nortel, JDSU, SciFam, and so on, which employed some over 8,000 people in the turn of the century. Since our humble beginnings of just myself and Larry, who retired a couple of summers ago, we've built a team of 11 experienced engineers and other support staff here, moving into this wonderful facility just under a year ago. We were very lucky that we moved in just before the COVID lockdowns began in the UK, and with the help of Wayne and the other people involved, we were able to continue operations throughout 2020, and looking forward to continued growth as we go forward from here. As you saw from some of the earlier presentations, there are great facilities here, which we take great advantage of. We work quite a lot with Martin on the Palomars and in the collaboration or prototype facility downstairs. We've collaborated with many of the other members of the local community as well. Effect Photonics, we have a long established relationship with. And I just want to show you now some of the facilities that belong to Bay Photonics here at Epic.
Fantastic. You know what, Glenn, every time that we discuss and I introduce you to many members, I always got great feedback of the discussions that they had with you. And it was all linked that always the design that you did for the packaging was taking parameters into consideration that others are missing, like, for example, cost or the risk on design for manufacturing or the different tolerances between prototyping and production. And that's something that I really applaud, and I really think that this makes Bay Photonics very different. And the Effect Photonics is partly a success story of Bay Photonics. You didn't say, but I can say anything. They pay me for that. I am curious of what other companies can help you. So I'm going to ask you, before we open that door, if you could give me the Santa Claus Christmas list item for the next client of Bay Photonics. I will find it for you.
The next client. Well, all our clients are another burgeoning in Effect Photonics would be a Santa Claus request, I think. You know, someone who's got a fantastic new product idea, needs help taking that into production, helps
making that manufacturable. We can provide that expertise, as I said, from many decades of knowledge of photonics packaging. We have some great facilities, which you'll see some of in a moment, that we can help bring towards their idea to fruition, to make their technological concept a reality. We can do that in small volumes initially, and we can obviously make those in fairly high volumes, utilizing some of the automated equipment that we have at our disposal here in EPIC. So
now everybody's intrigued. I have the spectrometers from Wasatch Photonics, very intrigued. I have the technology, Rhydon technology is also very intrigued. Let's open that door and show us the magic.
Well, this is only an office, and an idea of some of the facilities that we have, that as we mentioned, that we have a nice area where we can work safely during the COVID restrictions.
It's a magical office, by the way. But yes, and then what else coming?
And there's another office. Again, this is where me and Andy sit. So there's just the two of us in this huge office at the moment. We have some support staff in here under normal times as well. And now the more exciting stuff, we're going into the labs. So we'll walk through the changing facilities, and I'll show Andrew into the room, and I'll come back out and get changed so that I can join him in a moment.
Okay, so Andrew.
This is the dream factory, Jose.
Now we are talking. The offices were beautiful, by the way, but now we are talking. Show me.
This is the real deal. So here we got John over here, and John.
Hey, John.
John, tell us a little bit about yourself and what you're doing.
Yeah, my name's John Coombs. I'm one of the engineers here that build exciting photonic devices. And on this part of the lab, what we've got is the mechanical assembly side.
So what are these machines?
We're looking at manual wire bonders. So we have gold ball bonders, and we have an aluminium wedge bonder on this side. And I'm currently just setting up on a quantum device on the gold ball bonder with 25 micron gold wire. And yeah, we'll bond up the
so it's die bonding, wire bonding.
Wire bonding this one, yeah, and we have a die bonder, semi-auto over in the corner, just over there.
When it comes to design for manufacturing, of course, you're doing the manual wire bonding to have the prototype as soon as possible. But is there any lessons learned that you give afterwards? Because, of course, Bay Photonics works on design for manufacturing. So how does it work from the transition to the manual wire bonding to have the customer being aware that the first package is suitable to volume production?
Yes, yeah, that's quite true. Yes, we do. We feed back to customers and let them know what the pad quality is like, whether the wire bonds actually take well. We can perform bond pulls with that. In fact, downstairs as part of the collaboration lab, we've got a Zytec die shear tester downstairs, which allows us to perform bond pulls. So we use that quite often, and we feed back to the customers to let them know the quality of the pads and what the wire bonds are like, and if in fact any of the pads fail.
And if these devices, when we make the prototypes, where can we make them in volume?
In volume, we would use the auto bonding equipment, which there is some downstairs in the collaboration lab, which we use. Upstairs in the clean room, we've got an ESEC gold ball bonder upstairs that we can use for volume manufacture. Yeah.
That's great. And once we've got them up and running, what about coupling light in and out of them?
Once we've got them all coupled, then we go over to the other side of the lab, which my colleague, another John, is over there, and we've got alignment rigs over that side, which allows us to progress.
Hello, John.
Hello, John.
John. So we're not all called John, but this is another John.
Yes. Well,
what are you doing here, John?
I'm aligning a 780 device up, so once it's finished wire bonding, we bring it onto the rig, and as you can see here with the chip, we align the fibre onto that to get as much coupling out. The system we've got here with the piezo, we can actually get up to 17 nanometer steps on it, so that we'll be fairly accurate.
So 17, that's 17 nanometers.
Yeah.
Great.
But it's very, very accurate, so it is. Yep.
And what sort of efficiency, coupling efficiency?
Coupling efficiency, again, that depends on the chip, the properties of the chip. Typically, you would look for about 88% coupling efficiency. Sometimes it's 50%, depending depending on the, as I say, the chip in it and the lensing of it. But you know, in general, we'd be looking for about 80 to 90% coupling.
And can we do polarization maintaining devices?
Yes, well, this is set up for the now for the it's a PM device it's on the now, but we've also got our splicer here, so we can do PM splicing as well. So we're pretty well set up here for things. Really well big setup.
Historically, Bay Photonics have been one of the key partners that we had for the design of hermetic packaging. In the first presentation today, we heard from Martin about the idea that hermetic packaging is perhaps less common nowadays. I would like to ask you, Andrew, and of course, John, hermetic packaging is still an important part of Bay Photonics design for manufacturing?
Yes, this package that's on just now is actually a hermetic package as well. So this will be sealed up. I don't know if you can see me.
I would like to ask our camera expert if could show us this screen a bit closer, because I really want everyone to see this hermetic packaging from close up. The top camera, yes, that one. Oh, yes.
Yeah.
Yeah, so that's still, I mean, that's still a requirement for sure. Although, oh, Glenn can.
Glenn is my hermetic packaging expert, the hermetic packaging guru.
So, yeah, hermetic packaging is still definitely a big requirement in certain industries and for certain sectors. There's a lot of move to non-hermetic, of course, but I think it's got a long-term future, and we have some very good ideas about reducing the cost of packaging on hermetic devices, moving a little bit away from the traditional gold box that you saw John demonstrating just there, but that's going to take a little bit of development work yet, but I still think there's a good case for continuation of hermetic packaging, and we take delivery of a seam sealer here next month, and Bay Photonics are looking to procure projection welding equipment as well during this next year.
Glenn, we are seeing now, this is a fantastic era for interactive photonics outside the telecom market. We are seeing now entering different application fields. You're having a start on space, but the automotive is coming. The automotive is coming with harsh environments requests in hermetic packaging and price requests on telecom. This is when the best or worst of both worlds are coming together. Do you have any ideas to reducing the cost while keeping the reliability?
Yes, as I say, I mean, a large proportion of the packaging cost is in the packaging assembly rather than in the chip. And I think in terms of 80% of the cost of a product is in the packaging, and a lot of the cost of that is in the materials themselves, such as the gold box. So we have ideas about using different materials other than gold boxes, which will give us more stability longer term, as well as providing a cheaper material base, and also a quicker turnaround on NPI, new product introduction, due to the way we can manufacture those particular devices much more quickly.
Glenn, the packaging is 80% of the cost.
Mm-hmm.
And testing is another 80%, so actually it's 180% of the total cost. Glenn, seriously, when it comes to testing, is Bay Photonics also active beyond the packaging to provide testing to the companies who need full know-how of the result of the packaging?
That's something we're looking to extend our capability. Obviously, we have basic testing, if you like, in that the alignment technique requires us to do some testing. We'll go next door in a moment to look at another facility for some of the quantum packaging that we're doing, where we have a little bit more testing capability as well. But,
before we go next door, I never travel alone. I always bring friends with me, and I brought Matt from Keysight today. Matt, thank you very much for being with us. I'm very interested in bringing the packaging companies and the testing equipment together. That has been a recipe for success of many companies in EPIC. Keysight is very interested, actually leading now the testing equipment for PIC. Is there any potential opportunities that come to mind when you hear about the packaging and testing solutions that Bay Photonics is offering their customers?
Well, I certainly like to think so, but I'd have to have a deeper conversation to find out exactly what you wanted to do before committing. But certainly, we're already working with Effect Photonics and many other companies in your field. So Absolutely. There are always opportunities for partnerships and for working together, and we'd be more than happy to speak to you further about it.
Glenn, when it comes to the testing that that Bay Photonics is looking into, are you looking most at dynamic high-speed testing, or is more IV curves and just functionality testing? What is the ideal dream, the preferred future that you have for your testing services?
Well, you asked the question earlier on if money didn't matter and we could wave a magic wand. We would like to provide an end-to-end facility to our customers to give them complete development and proving of their products. So we would like to be able to test whatever it is they need testing. Unfortunately, test equipment tends to be quite expensive at the state-of-the-art high-end level. So at this moment, we're more just the quick functional test. As you see, one of our newest pieces of equipment is a nice Keysight source meter here. So
I also noticed some of your vintage Hewlett-Packard models as well, and I guess the good thing there is it proves that equipment made by HP, Agilent, and now Keysight lasts a good 20-25 years, as the case of some of the kit that you've got there, and that's great to see as well.
Yeah, some of our equipment's a little bit even older than that, but it's still functional and it does a very, very good job. So yeah, we continue to use that. As we grow the business, we'll be getting more newer equipment in, more flexible, more reliable equipment. Although, as you say, some of this old ILX equipment is very reliable.
It is indeed very reliable. I've used it and I love it. I love that HP machine that you have there. I just love it. But I want to, because you told me you want to show me something next door, and I know Paul is waiting there. So tell us what is next.
Okay, we'll go next door to.
This is so cool when you're actually walking with people and they are showing what, the only problem is that we cannot all go for dinner afterwards. And Glenn is so much fun to have dinner with. Oh my God. So here we are in another laboratory and we're meeting another one of your colleagues.
Another of our engineers, not called John.
No, this isn't John, this is Jeff.
Hello.
Jeff is all alone in this lab. Why is that, Jeff?
Because nobody likes me.
Well,
I already like you.
Oh, thank you.
Yeah, and that means a lot. But seriously, this is our high power lab, and what are we doing in this?
Yeah.
Lab?
So the reason I'm in here on my own is actually because we produce high power collimated beams at wavelengths which are dangerous to the eye. So that's why I'm here.
And what are these machines here? What are these instruments?
Okay, so we have our translation stages here. So this is where we manipulate the components, the optical components. And these are nano positioning stages, and they have a coarse and fine positioners on the stages and integral piezos.
And the resolution, what's the resolution?
So it's a continuous movement of around 15 to 20 microns with a controller which has a resolution of 10 nanometers.
10 nanometers.
Yeah.
Right.
So the stages, we have XYZ translation stages, and you can see the sort of little manipulators that hold the components like a filter and a lens you can see on here. We also use cameras for orthogonal view of the components when we're placing them. And to aid that placement, we also have video pattern generators on the screen, which are very, very useful.
That's really truly great. Do you also foresee the need for infrared cameras to optimize the accuracy? Because if so, I can find you great infrared cameras. Always trying to sell. That's my passion.
I'm sure, Jose, I'm sure we will want, again, with the magic wand, we want everything that everyone can offer, because we're trying to give the customers what they want. And, as we move forward and develop into new areas, this is mainly quantum equipment that's being manufactured in here. We make QRNGs, we make QKDs, single photon detectors. This is, I believe, a gas detector.
Yeah, so I'll come on to that, and shall I just finish the?
But so yeah, yes, I'm sure we could make use.
Yeah.
of
So what are you doing then? What are you doing?
So the other things we have, not only translation stages, but we also have rotation stages, and we have goniometers for rotation, pitch, and yaw. Okay, so the components are snap cured in place with a highly stable UV adhesive, industry known adhesive, and we use the UV cure system here, and this can sort of swivel into place and focus from two sides onto the component to make sure it's all program controlled. I flick a switch here and the program runs, and so it's all very consistent. So that's that alignment equipment. We have instrumentation also, so we have an open loop and a closed loop controller for the integral piezos. We have some equipment here, typically that we're using for some of the devices we're making at the moment. So we've got a high precision voltage device where I've been testing out a piezo which is integral to the device. We've got laser drivers. We have an oscilloscope which is actually at the moment hooked up to a scanning fabric pero, which we use for checking line widths of the lasers. We have tech controllers for the Peltier coolers, and we have an SMU for monitoring photodiode currents. We have some other equipment also there. In addition to that, we also have we've just bought a beam profiler for one of the devices.
Is it there? I don't see it.
No, yeah,
Beam profiler.
Beam profiler. Basically, it's a CCD camera because it's down at these 700-800 nanometer range. That's going to strap on the front here on a rail. I've got a rail, so that will be basically strapped over here.
So let me do my magic here. For all the EPIC members, it's 193, I think, right now. For all the EPIC members, if anybody has infrared cameras or any other technology that you want to test for the packaging and assembly of silicon photonics or photonic integrated circuits, you want to enter that market, this is a great opportunity. Contact me and we'll make sure that these people can test your equipment in their fantastic setup. Glenn, I'm going to make magic here.
Sounds very good. Thank you.
Back to Rolf.
We'll be in contact with you.
We believe in your magic, Jose.
I know you do. I think we have to move on to the next presenter, but it was so amazing to see Bay Photonics live. Can you walk me to Effect Photonics?
I think with the magic of television, we can do that.
Let's walk together. All my friends with me right now, I think we are 70 friends walking with you in EPIC to Effect Photonics. Following Andrew Robertson, all the way opening the door. And in the meantime, I would like to remind people that EPIC is really open for cooperation. I think we had from the Torbay high-tech cluster, is Jason back in the room? Jason.
Yes, hi, Jose.
So when a company wants to move in EPIC, in Torbay, how can you help them? Is there any subsidies, any support, any financial help that you can give to these companies?
Yes, it certainly is, particularly for the high-tech companies that we're looking to attract here to Torbay. We can provide them with Invest in Torbay soft landings funding, and also a regional level, our Heart of the Southwest, LEP. We can work with companies to put applications through to receive maybe anything up to £150,000 if they're looking to come and locate into our region. So yeah, there's a nice healthy package of support. And coupled with the support that we can provide here very locally at EPIC, working with Wayne, obviously, as the centre director, and myself as the investment manager here for Torbay. So we're very keen to speak to new companies and introduce them to our cluster.
We are going to see one of your iconic companies in the Torbay high-tech cluster now. I'm super excited for this. People who know me, they know why. We're going to see Effect Photonics. One of the success stories, almost, I think, about 200 employees working on Effect Photonics, an idea from the Technical University of Eindhoven, becoming a huge success story. Thank you very much, Paul Rosser from Effect Photonics, for being with us today.
Okay, thanks very much for that introduction, Jose. Yeah, so I'm Paul Rosser, COO of Effect Photonics. So I have responsibility for the Effect facilities here in the UK, and specifically here at Epic. So Effect has had its UK base in Torbay for about 5 years already. And over that period, we've really benefited from the tight collaboration with some of the companies based in the Bay and that are now also based in Epic. We've had tight links with Martin Davis from Palomar, and with Bay. In fact, they built our first prototypes. I mean, this is their strength, and we certainly use them for that. And you can imagine that, I mean, when we first set up a facility in the UK, there were 2 people there, just 2 of us. And so you can imagine that having a group of technical experts next door that we could call upon made a huge difference. We could suddenly double or triple the size of our team just by having the right conversations and perhaps the right agreements. So we're really strong on the importance of the collaboration here in Epic. So
for me, one thing that I'm always amazed when I talk to you is how fast you have gone. The company has gone from the idea of having a design suitable for manufacturing indium phosphide technology. That's 10 years ago, when indium phosphide is not what it is today in Interactive Photonics. Indium phosphide was only for DFB lasers at that time, and Interactive Photonics was just emerging. And you have really set up a production facility and already for 2 years shipping package transceiver in a pluggable form factor. And that's really something to be very proud of. I feel proud of being European when I talk to you.
And honestly, within the whole company, there is a serious pride around that. But it all came from this original, originally they're a group of bright PhDs from Eindhoven, and they were given advice at some point, try to find somebody with experience in the industry to work with, which they did, and that led them towards Torbay. So then you have this mixture of really bright ideas coming from straight from the university, and a group of people linked to the collaborative partners that we've already talked about, with the experience of actually having done manufacturing before in the old Nortel Claro background.
To all the friends that came with me, you are about to see something really special. Being inside the prototyping lab of Effect Photonics is something, a dream of mine. I wanted to be in there for many years. It was not really something open for showing. Today, they are looking for cooperation, strategic cooperations. They're going to show us the prototyping lab, right, Paul?
Yep. Our current manufacturing facility, our main site, is about 3 kilometers away. We've got a wonderful location by the sea, as thank you showed in your opening video. That was great. Here we have a very complementary facility, and frankly, we are new boys here. We're one of the more recent starts. So yes, we have our own offices and labs, but the biggest value to us at the moment is the prototyping lab that's available here, where we can do advanced work with Palomar and with the equipment that the Epic Center have installed recently.
Fantastic.
So, but I do want to say that I think critical for us is being able to build on the legacy that's here and move it forward. Because the other thing that's not been highlighted too much is we're right across the road from the college, where we can get a fresh group of apprentices, and we can tailor the courses there to suit the needs of this center. So that's bringing out another point. But I can see the time, so let me move on.
Don't worry about the time, but I'm worrying because I'm seeing there my friends Jonathan and Alex, super excited next to some equipment. Jonathan, you look fantastic with the clean room environment as well. It is so great to be inside a clean room. What are you going to show us?
So first, making sure I unmute myself. So hi, Jose. So we have behind me the Mitutoyo vision system. We have our first 4-inch indium phosphide wafer that Alex is checking out the features on that wafer. Again, just to cycle back, indium phosphide is a very difficult material to work with. 4-inch represents state-of-the-art, unlike silicon, which tends to have wafers much bigger. This for us is a significant leap forward moving into 4-inch technology.
With the risk of something falling, which I don't want to, is that possible to get the camera a bit closer to the wafer? I don't know if
Well,
I'm asking too much, and you are free.
You might be.
Welcome to say no to me.
Do my best to lift my laptop.
Yes, I really want to see the 4-inch wafer on indium phosphide. It is still difficult to get an indium phosphide wafer of 4-inch for photonic integrated circuits. Let me highlight that part. I know there is a strong cooperation between Effect Photonics and Smart Photonics, and they are watching Smart Photonics. It's great to see you. It is great to see the inspection that Alex is doing. Alex, when you are inspecting a 4-inch wafer on indium phosphide, what are you looking at?
Looking for any defects, making sure it's the right size and that it's being cleaved correctly.
And you're using the Mitutoyo equipment. I don't know if I can ask to get the camera a bit closer to without breaking any IP or confidentiality issues. Check any closer to see what Alex Ward is looking at. She's inspecting a 4-inch wafer. I can see the waveguides, yes.
Yeah, so Alex is looking at on these, the picks on these, on this wafer have multiple tunable lasers. They have wavelength lockers, and there's amplifiers and modulators.
Truly, truly fantastic. At the end, indium phosphide technology allows you to integrate laser detectors, modulators, any active component inside a waveguide with the need of hybrid integration. What else? What else do you want to show me before I ask questions and also open the floor for questions?
Okay, so to show you the products, the end products that we make,
yes.
Small form factor pluggable, or SFP, optical transceiver. These products are currently going into 5G mobile phone masts. So they have to work over what's called the industrial temperature range, so
yes.
-20 to +80. And just to show you the inside of one of those, so the pick on that wafer is about the size of a grain of rice. Grain of rice. I'll be impressed if you can actually see the pick inside there. And we get over 1,000 picks off that 4-inch wafer.
Truly fantastic. Operation temperature between -20 to 80 degrees C. So the temperature control, the stability of this chip is huge. I remember talking to Bob the wine doctor 10 years ago. He told me, Jose, the photonics was the easy part. Actually, the electronics to actually make a transceiver is really what is going to be the huge value for Effect Photonics. Do you agree with that initial statement from Bob the wine doctor 10 years ago?
It's the whole, without intending to make a pun, it's the whole package, getting everything to work. And of course, just to cycle back to the earlier conversation, no gold boxes are sacrificed in the manufacture of our transceivers. It's all non-hermetic. So getting all of those elements to work correctly for high volume manufacture, hundreds of thousands of units, it's taken us all this time to get to here, and we're now doing it.
One thing that I would like to ask you, we are talking about having a fully packaged device suitable to shipping for 2 years. You've been already shipping transceivers. Is this the high volume market that you are targeting? Is that something that you need further cooperation with new manufacturing centers that can actually help you to even ramp up to even higher volumes as what you are getting out of Torbay? Or is the idea, I would love that, to get everything manufactured in the UK?
It's certainly an aim of the company to stay within Europe. So yes, yes, we are looking at how to significantly ramp our production. And so the automation technologies that go along with that, we are looking at very closely indeed.
Paul, this is an EPIC meeting. It's a meeting for cooperations. So I'm going to ask you the EPIC question. I know you were prepared for this. What can you do for the other 693 members of EPIC? And what can they do for you? What ideal room for cooperation or a Christmas wish list?
I mean, really, what struck me about working within EPIC and also in our previous facility is just the value of collaboration. And so I think that having a forum where we can share ideas from industries that are related but not competitive is hugely valuable. So, engaging with other companies, say with similar problems, I think would be number one. And I think of in terms of what would it be helpful to have across the road from us here or other occupants of this building. And you can imagine that having a customer development lab, so that we can really keep in touch with end customers in our same technology, would be hugely beneficial. And of course, we can reciprocate in terms of what can we do for other partners if there are other companies, facing similar challenges in non-competitive industries. There, we can talk.
So for me, one of the things that has been very unique for Effect Photonics is that always you've been targeting talking to the customers of your customers, being one step ahead, talking to telecom operators, talking to data center manufacturers, and being one step ahead on what their integrators are going to need, what their vendors are going to need. And that has been the stepping stone to the industrialization of indium phosphide photonic integrated circuits, which is in a large part thanks to you, thanks to Effect Photonics. I'm extremely proud of being, many people know this, being part of this in the early stages. I was there. I'm extremely proud of seeing the huge growth of these 200 employees working on indium phosphide photonic integrated circuit transceivers already enabling 5G. Thank you so much, Paul, for this.
Thank you. Thank you.
So let's continue. Walk me to somewhere. I want to see something else. I was told that I was going to see some automation equipment machine called Queensgate. I want to go to the next step. Let's walk virtually to Queensgate, and Alison Raby is here with us. Queensgate Friar Scientific. Thank you very much for being with us. The first ever epic encounter. So don't be worried. It's just a friendly attitude that we have here. Tell us a bit about Queensgate, and most important, how can my 693 friends help you be even greater?
Okay, so Queensgate is the nano-positioning brand of Friar Scientific. And we were really proud to be the first tenant of EPIC. We moved in August 2019, and we moved from an old factory that was just 3 miles away. So it's a really great environment to work in. Now, Queensgate was founded in 1979 as a spin out from Imperial College. And actually, throughout its history, it has been involved in photonics. But from the perspective of what we do now, we were the first company to use capacitive positioning sensors in piezo stages and actuators. And we're experts in high performance. And by high performance, I mean sub-nanometer positioning and high speed nano positioning. Most of our business is OEM manufacture. We don't have a big catalogue, but we work in partnerships with our customers to meet specific demands. So for example,
we are seeing now the tendency is to go to 100 nanometer, 200 nanometer positioning. We are seeing waveguides and silicon photonics 200 nanometers. We are seeing very, very high accuracy equipment. Is that your chance? Being at EPIC gives you a chance to work with companies working in nanophotonics, photonic integrated circuits?
Absolutely. I mean, we are the company to work with if you want very high performance positioning and speed, because quite often companies are looking for a high throughput. So if you need, high performance, high speed, then talk to us, please.
Well, what I have seen in the last years is that we need 6-axis positioning. So the companies, I don't know, PI, Thor Labs, Aerotech, are doing, or EPIC members are doing these 6-axis hexapods, which sometimes for many of the applications that, for example, Bay Photonics are targeting, could be a killer. When it comes to this accuracy for speed and low price, what is the position of Queensgate Friar Scientific?
Well, in terms of performance, I mean, we actually are looking at development of our 6-axis capability at the moment. So that's something that we're, very active in. Now, I think the other part of this is, Queensgate stages are used to test half the world's hard disks. So every single read head and every single hard disk produced by one of the big two are tested using a Queensgate stage, because they need not just nanometer positioning, but they're looking at low picometer levels of precision, right? So, this means that we work with our customers to deliver specific requirements, and it requires us to have not just excellent stage design and choose the best material, but we have, because of all our systems operating in closed loop mode, we need very powerful electronics. And I think it was mentioned earlier, I mean, our electronics operate not just at nanometer levels of noise, but you're talking, 10 picometer levels, because that is how we can deliver performance and speed. We can operate our stages at over 40% of their resonant frequency because we control the acceleration and the deceleration. And we're able to operate our systems at a constant velocity to take advantages of very fast imaging techniques.
All right. So you talk about the hard disk, which, by the way, I work a lot with Seagate in the past. We had actually lots of work with them, and I was amazed on the evolution of this. But so how is the market looking like right now, in which we are going to solid state, in which we are actually addressing the new ultra fast laser writing directly on glass? How does the market of hard disk look like now for a company that is very good at making ultra fast stages?
Well, I mean, if this is the interesting thing where you're talking of, I mean, we make ultra fast stages. That's just one of the applications of what we do. But I think if you look at Seagate, they whilst there's this idea that they're being superseded, I think the reality of the fact is that they're not. And when you talk, their business plan is still strong, and they're still delivering very good profits for their shareholders. So, I think whilst solid state has got some real great advantages when it comes down to long-term storage, I think the traditional methods. But you need to talk to them about that. That's not.
We talk to them a lot. By the way, if you are watching us from Belfast, my friend of Seagate, it's great to see you again. Alison, I was told that we are going to hear a little bit more about the link to integrated photonics. Is there anything that I can tell to all the companies that they have integrated photonics, nanophotonics, maybe ideal of quantum technologies, reasons for them having a chat with you or your colleagues?
I think the main thing that the message that we would like to get to people is if you need nano positioning and you need fine positioning in whatever capacity, whether that be in a testing machine or whether it be in terms of optical positioning or laser positioning, then we would be really happy to talk to you and see what we could do. I mean, one of the things that I would like to do now is to hand you over to Sam, who is the site lead for Queensgate and has been instrumental in a lot of the automation of our test and measurement, which is critical.
Sam Frost.
And he's going to talk about some of our products. So you maybe get an indication of what we do.
Sam Frost looks super excited to show us, and I'm super excited to hear. Sam, thank you very much for this. All the way from Torbay High Tech Cluster, Queensgate. Tell us what you do, and most important, how they can help you.
Yeah, lovely. Thank you, Jose. So hello, everyone. My name's Sam Frost. As Alison said, I oversee Queensgate's production facility down here in the EPIC building. So I've been with Queensgate for coming up to 10 years now, which makes me actually the shortest serving member of our staff down here. So that gives you an idea of the experience and the knowledge that we've got in the people here. So I'm going to give you a quick run through of a few of our products that we build. And give me a moment while I adjust the camera. That should be reasonably good.
I love when people show us the camera to see.
Okay, so
see? Yes.
I'm going to struggle to get these in focus properly, but so this is our first stage. This is our highest volume product. It was developed back in 2018. So the design goals for this were for a very high speed and high resolution stage. And the result is a resonant frequency of more than 5.5 kilohertz and resolution of better than 93 picometers. So that is industry leading performance for a stage like this. So as Alison mentioned, stages like this one that test half the world's hard disks, and for that reason they need to be reliable, but also they need to be very quick to service or to replace. So to that end, all of the calibration for one of these stages in terms of scale factor and things like that is all stored inside an EEPROM inside of the connector. So if there was something was to go wrong with the stage or something was to go wrong with the control electronics, we would just swap in a new stage and everything would read in and pick up immediately. So that's very useful to high throughput applications. So the next stage we have here, a very heavy one, so bear with me. So.
Wow, what's that? That
So,
looks heavy. How heavy is it? You look also very strong. So
it's roughly 2 or 3 kilograms this stage, so relatively heavy, and it's actually designed to take a 12-inch wafer. So a wafer plus the chock, which can weigh anywhere up to 8 kilograms. So obviously it's quite a big stage, quite a powerful stage, designed to move heavy loads. So the range on this stage is around 120 microns, which is fairly large, obviously, for such high range. And for a 1 micron step over that range, we can settle to within around 13 milliseconds. So a very fast, very sort of high performance, heavy load stage. Moving on to the next one.
I'm going to bring to the debate my friend Tobias Müller from Tech, because if Tobias doesn't find this useful, then it's not useful, but he's very polite. Okay, Sam, continue. By the way, Tobias Müller is the CTO of Tech, one of the key companies that we have for equipment for active alignment-based automation, packaging, assembly, and testing of photonic integrated circuits and semiconductor lasers.
Okay.
Thanks a lot, Jose. I'm looking closely. Super interesting. Please continue. Don't want to interrupt.
Thank you very much. So the next 2 products I'm going to go through were developed more generally. Obviously, the last 2 are more towards specific customers, specific requirements, whereas these 2 are more for the microscopy market as a whole. So this is our SP stage. So this is designed to hold a sample. So in here, in there, you may be able to see, you may not. You have a couple of magnets in there. So you would sit a sample in there, and then the whole stage moves up and down in the Z-axis. So what this allows people to do is to mount a microscope over the top, fixed microscope, and to basically move a sample up or down underneath the microscope in order to allow people to autofocus or to image across the range of sort of Z-axis on a sample. So similarly, we have another stage designed for the same sort of market in a slightly different way. So this is our OP stage. So this one would sit directly on the bottom of the microscope with the objective hanging below. So rather than holding the sample and moving the sample up and down, this one holds the objective and moves the objective up and down. So similar sort of applications, auto-focusing or imaging of the whole of the Z stack. So usually on stages like this, with this sort of performance, sort of sub-nanometer performance, you would be expecting quite short ranges because obviously you need quite high stiffness and so on. So these stages here, this one in particular is a 400 micron stage. The one I showed you just now, the SP stage, is a 600 micron stage. So quite considerable range for the performance.
Let's talk to your potential customer, because if you don't have the customer, we are missing half of the point. Tobias, when you are looking at different stages for the automation and assembly based on active alignment, what is the first question that comes to mind? And I know you have great suppliers already, but let's consider new ones. Tobias, you are muted, and I have a mug to celebrate that.
Excellent. No, it's super interesting. I'm looking very closely. For us, it's always like the job to choose the right kinematics, the right motion tool for the right application. So we need to have macro positioning tools to bring tools to the right position. Then we need to have really fast actuators with maybe small step size to do specific testing tasks, fiber coupling tasks, and so on. So let's say in general, I can never know enough about components which are there on the market, and yeah, always interested to learn which is there. So yeah, I'll be super happy to receive your your component portfolio.
Yeah, absolutely. So Prior Scientific, which is our parent company, they are generally into the sort of more coarse positioning, as you mentioned there. So they would supply a longer range, more coarse positioner.
Yeah.
On top of that, we could mount one of our stages, so a small stage like this over 28 microns, or a larger stage like I showed you there over 500-600 microns, and they would supply you with your high accuracy, high precision movements.
Perfect. Yeah. So generally speaking, it's for us, it's the art of our, let's say, craftsmanship is to combine the correct tools to get the most powerful tool suitable to the specific assembly tasks. So assembly, packaging, testing tasks. So yeah, happy to learn and see what we can maybe use your components.
Definitely. I think that's where we've got an advantage having Prior Scientific, because we have both sides of the coin. You know, it tends to be that you have to focus on high precision or you have to focus on decent coarse performance. And we have the advantage that we have two units doing both. So,
and you have there a closed loop control. I can see
exactly.
Exactly, yeah. So I'll be going through that one next. So this is our 6000 series controller, and this is a 3-channel version, as you can see, 1, 2, 3. So this could be used for a single XYZ stage, 3 axes on here, or 3 X stages, or any combination thereof. So all of our controllers are fully digital, and they've got a number of advantages in terms of due to that digital setup. So you've got things like we have auto range balancing. So for example, if you were to one day, you have a hot spell and suddenly your lab is 5 degrees hotter, with most stages you would find you'd be suffering range offset, you'd be suffering a degradation in performance because of changes in loop bandwidth and things like that. Our stages have a lot of technology in there that compensates for that, takes that out. So essentially all you need to do is run one command before you do your testing, and you know that your stage is dead center, dead square, and everything is working well. So another thing we have that's in here that's a fairly recent addition is what we call function playback. So you can load in a specific function to the controller, say like we were talking about before, like a Z stack where you would step up slightly, or you could have 2 axes, you could have an X, Y, and you could raster scan that to image an entire profile. So we can program all of that into the controller, and then at the press of a button, the controller goes off and actions that on its own. So that certainly helps with the automation side of it, taking away user input.
You do have really like the solution when it comes to ultra fast nano positioning, the solution that companies like, for example, Tegema that we have in the room, focusing on active alignment, Tobias from Ixemtech, there is lots of cooperation here. I know you are prepared for this. Can I ask you the epic question? What kind of potential collaborations do you have with the companies in the supply chain of photonics? What can they do for you? And what can you do for them?
So obviously, as we've talked about, as a company, generally we target markets like microscopy and basically any kind of high precision positioning. So we're very good at incorporating our technology to OEM solutions. As Alison said, we generally don't do things off the shelf. We generally like to work with our customers to find out exactly what their requirements are, exactly how they're going to apply these things, and exactly how we can give them the best performance available. So I think any opportunities along those sort of lines where we have sort of very niche, very high performance requirements, those sort of areas would definitely have our interest.
Thank you very much.
The more the EPIC group grows, the more likely we are to see more of those opportunities.
Thank you very much, Sam, for this. There is a lot of potential cooperation. I am a strong believer of the test before invest. So I would say, if anybody wants to try somebody else's equipment, I pay for the shipping expenses. I'm not afraid of making that statement. You know what, Sam? In the beginning of the meeting, I promised that I would go back to Martin. So because he said, I have something to show you on the inspection side that you will be amazed. So let's go back to Martin Davis from Palomar Technologies. Martin, I saw you about 1 hour ago. You were amazing. What else do you have to show us before we close this fantastic meeting, Martin? We're still inside the clean room, that I can see. We cannot hear you, which is, I can see the Nikon logo behind. I can see the camera actually focusing on what this seems to be some kind of tweezer. And we see the wire bonding, but we cannot hear you, which is making me a bit nervous. I think we have also Wayne Losky in the room. Wayne, we are reaching the end of the meeting. We have some problem with the sound of Martin from Palomar, but I'm sure he will find a solution. Martin, can we hear you now? I think we have a problem with the sound. We can't hear you, which is it's a pity, because the equipment for inspection that he was going to show us is a very important part of the services. Wayne, oh no, I think we can hear you now.
That's me, Jose. It's Wayne. Hi.
Wayne, I had to say, I'm amazed. I'm amazed by all the things that we have seen, so many potential cooperations. And I think Martin is holding something on his hand, but I don't know if we can hear him now. Let's see. I think we have a problem with the sound. So.
All right, thanks, Jonathan.
Okay, so we use the camera of Effect Photonics. That's a way of cooperating. Martin, tell us what you're going to show us now.
Yeah, I just wanted to mention, as part of our ongoing collaboration with EPIC, Palomar are consigning this 8100 ball bonder behind us. So this machine is going to really help us with PIC flip chip applications. So we can run really highly accurate defined planar bumps with this machine. And it's about $250,000 worth, and it's arriving next month. So I know all the collaborators and partners here at EPIC are really keen to try that one out. And I also wanted just to show this Nikon Joule SEM machine. So there's a beautiful wafer image here of the Effect Photonics Shark 5 PIC, I think it is. Lovely image. Wayne has worked closely with these partners and has got really good relationships with them, and he's updating and upgrading this SEM with EDS technology, and also we're getting a platinum sputterer in so that we can really get the most out of that SEM technology.
So all these machines are free to use for the people that you have there as cooperators in the EPIC building?
That's right. So,
oh wow.
Yeah.
Yes. Yeah.
Go on, sorry.
So the concept of EPIC, Jose, is businesses come in, take a unit within the building, and they have access to all this equipment overnight. So that is really, in answer to your magic question, that's what EPIC can bring to your members. So not only the £2 million worth of equipment, it's the expertise of people that can drive the equipment as well.
Well, this is out of this world. So anybody who gets any manufacturing for any foundry of integrated photonics, and they need to inspect it, they need to examine the way of doing it into packaging, they can actually use some of the know-how and actually getting all these machines servicing for them towards the pilot production and suitable to design for manufacturing. I think that's truly unique, Jonathan. Yeah, actually, Wayne.
Yeah, that's this is our XYZ Tech state-of-the-art destruct tester. So when we're rapid prototyping and doing process development for collaborators and customers, we can non-destruct and we can destruct test wire. We can wire pull, ball shear, die shear. And
can you get closer? I love this machine. Yeah. The non-destructive testing is great, but the destruct testing is something that gives me goosebumps. Let me see.
So this is the XYZ Tech. I don't know about the lighting here at the moment with this camera, but we've got the die shear cartridge lined up here. Let me see if I move that out of the way, you can see it better. All right. So we've got a transceiver in there ready for some testing.
It is a great testing when you do this live. It is something fantastic. I do have already the feeling that all the different equipment that you have here for cooperation is all ready, is all active, and any company that needs to use it, any company that wants to use it, they can use it. And also, if they want to move in this equipment, they have something that actually can provide value. We even heard already from Jason Buck, the Director General of Torbay High-Tech Cluster, that there is even financing money to actually help the companies in this incubation period. This is truly fantastic. Thank you so much, Martin. I want to go back to Wayne. Wayne, I got goosebumps during this 1 hour and 22 minutes. It took 22 minutes more than expected. I have to apologize, but I really wanted the whole industry to understand what you're putting together here, Wayne.
Yeah, thanks for giving us this airtime, Jose, and I'm glad you enjoyed it. So what you've seen is just some of the equipment that we have. We're also considering active alignment to bring that into EPIC. We're looking at bringing software licenses into the building, 3D optical printing. So all of these things are on our sort of technology roadmap that maybe next time you come to EPIC, they'll be installed and ready. But again, these are all facilities that EPIC members can access by coming to join and being part of this EPIC. So hopefully you've enjoyed what you've seen. And yeah, we really look forward to you coming to EPIC and visiting us in person.
This is your preferred future. It was really clearly defined what we can do to help you help make that's preferred future. For me, my preferred future is to make sure that these companies over here find ways to cooperate. And it is clear, on one hand, Bay Photonics is providing services for helping the companies with the packaging. Effect Photonics is a success story, and if you want to be part of the success story, there's lots of room for cooperation. We really heard fantastic thing about how many equipment from Palomar is there ready for being used, and we also saw the fantastic stages from prior. And most important, we saw a great group of people who love working together. Wayne, congratulations on this. I got goosebumps. I loved it. I love every single minute of it. At the end of the day, this meeting is all about looking for cooperations. Today was a fantastic day because from Northbike, I can't travel, but I went to Torbay and I saw the EPIC Center, the Electronic and Photonic Innovation Center. And I saw stories. I saw ideas for cooperation. I saw business opportunities, and I saw people which I wish right now we could all go for dinner together, but we can't. But don't worry, soon we're gonna start traveling again and we're gonna meet each other. I just would like to say that if you want to get in touch with any of the people that gave a presentation today, or any of the people in the participant list that we're also going to publish, all you have to do is send me an email, jose.pozo@epic-asoc.com, and I will be more than happy to make that introduction. I love doing that because I love when people, companies, get together, and together they make innovation in photonics. Congratulations, all of you, for bringing photonics to a sustainable European technology development. This is the agenda of the upcoming online technology meetings. Next Monday, I'm talking about the green energy and how photonics actually can help that amazing industry these days. Until then, my usual advice, wash your hands, wear a mask, and stay safe because soon we'll travel again. Until the next time, be epic.